In this lesson, we're going to talk about rational exponents. What happens when we have exponents that are fractions? We'll get there in a second. But first, let's review some power rules. So here's some exponent rules or some power rules that we're going to run to that are important. We have our product rule that says if we have b to the m times b to the n, we add the exponents if we're multiplying these powers. Let's see where that comes from. The nice thing the nice thing about exponent rules, I should say, is that we can quickly convince ourselves of what they mean. So if we have x squared times x to the third, that's like x times x for x squared. X to the third is x times x times x. And if we multiply those together, well, what do we have? We have 5 factors of x. So that's x to the 5th. See how that works? What about dividing? So if we're dividing here, we have b to the m divided by b to the n. We're going to end up subtracting the exponents. Let's convince ourselves of that. So if we have x to the 4th over x to the 2nd, well, that's like having 4 factors of x all over 2 factors of x. And we could rewrite that if we want. Let's take 2 of those x's over 2 of those x's times. Now remember, when we're multiplying, we don't have a common exponent there, all right? So we have x times x times x. Okay, there it is. So this is like having x to the 4th over x times x there, all right? And all of this is just worth a big 1, and that doesn't change anything. So when you multiply by 1, so it's just x squared. So in other words, this is x squared. What happened? Well, we had 4 minus 2 equals 2, so we're subtracting the powers. If we have a product to a power, what happens here? Well, this means we have like x y to the 2nd power. Well, that's like having xy times xy, which we could rearrange as x times y times y. And that just means we have x squared, y squared. 2 factors of x times 2 factors of y. So we see that exponent applies to both. It's kind of like distribution, but it's not distribution. So you can think of it that way, but it's not. All right. Well, what about ab to the m power? We got a fraction to a power, so that's like x over y to the 2nd power. Well, that's like x over y times x over y, which is just x squared over y squared, because we multiply straight across. So we see that the power gets applied to both, just a to the m, b to the m. All right? Very good. Well, what if we have a negative exponent or a 0 exponent? Well, to see that real quickly, let's look at a pattern. If we have 2 to the 3rd, that's 8. If we have 2 to the 2nd, that's 4. If we have 2 to the 1st, that's 2. Now, what about 2 to the 0? What's happening? Notice that we're dividing by 2 here every time. Well, if we divide 2 by 2, we get 1. So 2 to the 0 power must be 1. See that? And if we continue our pattern here, 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, what does that have to be? Well, we're dividing by 2 as we go down. Divide by 2, divide by 2, divide by 2. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. And 1/4 divided by 2 is 1/8. So what's going on? Again, just cut it in half. Cut it in half, cut it in half, cut it in half. What's the connection here? Well, let me write this a different way. 1 over 2 is like 1 over 2 to the 1st. This is like 1 over 2 squared. And this is like 1 over 2 to the 3rd. 8 is 2 to the 3rd. So what's going on? Well, if we had 2 to the negative 1, it became 1 over. 2 to the negative 2nd became 1 over. 2 to the negative 3rd became 1 over 2 to the 3rd. All right, so what happens is when we have a negative exponent, it drops down to the denominator, becomes positive. So if I have x to the negative 3rd, that's going to be 1 over x to the 3rd. if we have x to the 0, anything to the 0, that's as long as x is not 0, by the way, we get 1. All right. So, oh, and there's one more rule that's not here that we're going to add to the list, and that would be our power to a power. So if I have b to the m to the n power, that's b to the m times n. Okay, and to convince ourselves of that, if we have x squared to the third power, let's say, well, that means x squared times x squared times x squared. And as we know from our product rule, we add those exponents, 2 plus 2 plus 2, okay? So that would be x to the 6th power, all right? Add the, multiply the exponents if we have power to power. So these are important rules to have down. And we're going to take this in the world of rational exponents. But first, I want to look at some examples real quick here of these. If you think you got this down, you can skip these examples and move on. If you want to copy them down and practice them real quickly, hit pause, try them out, and come back and look at the answers you can. So, what does this simplify to? So we have power to power, so this is a squared squared, because this power applies to both. And we have b to the 6 squared. And now power to power, we multiply. That's a to the 4th. And b, 6 times 2 is 12. That would be our simplified answer there. Okay. How about this one? So here we have this power 3 to the 4th. And we have x squared to the 4th. That's going to be x to the 8th. This x in negative 3rd. We can go a couple ways from here. 3 to the 4th, first of all, is 81. And we've got x to the 8th times x to the negative 3 here. And we could use our product rule here where we add those exponents. And that's x to the 5th. There's our answer right there. Okay. If you want to make that into or option 2 would be to take that and make that x to the 8th times 1 over x cubed. And this is x to the 8th over x cubed. And we can use our division rule and subtract. That's another way to get to the same answer. Okay. How about this one? Well, this one here, we got a bunch of division, so let's try our division rule, which tells us to subtract. So we can take our x squared minus the 3 there, so 2 minus 5 is 3, negative. And then we have 4 minus 2, that is 2. And then there's no z's on top, but there actually is. We can put z to the 0, because remember, z to the 0 is just 1. And so now we can take that 0 minus negative 4. 0 minus negative 4 is positive 4. And now we're almost there. We just don't want to leave any negatives in the answer. So we're going to take that y squared and the z to the 4th. And negative powers, take that downstairs. That'll be x to the 3rd. All right. So there's some examples just to get used to that. All right, well, what about fractional exponents? Let's look at that next.